Good morning. Well, it's morning here. It's 12:24 in the morning when I record this video. This is not a live video. This is a recorded video. There's no immediate threats if you're seeing this now. But we just come off the busiest 4-day period of warnings since our office spun up to a full 58 county warning area in 1995. And there were a lot of really good questions about a few different aspects of our warnings, our decision making, and our distribution that I wanted to record a video to talk about a little bit. Now, we've had worse weather. You know, it's mostly wind damage and hail. We've had bigger tornado outbreaks and stuff like that, but for individual reports and number of warnings, it was the busiest 4-day period that we've had. It was a combination of extreme summer heat and humidity, coupled with a couple little systems passing by. They got stalled out. That just led to that constant printer of severe thunderstorms. But we've got new types of warnings that some of you may not be familiar with that result in different dissemination. We set your phones off now, which we didn't do 10 years ago, for different types of warnings, and I wanted to talk about that a little bit. We can set your phones off now for warnings that include wind in excess of 80 miles per hour or baseball-sized hail or larger, and we did have both during this past event, and we made what we call the destructive tag severe thunderstorm warning decisions over the course of that. Now, how we make our decisions is mostly based on the radar. And when you watch your television stations or you pull your app up, you'll mostly see radar data that looks like this. We call that reflectivity. It's the amount of energy being bounced back to the radar. But we're using to make decisions, there's about 12 different, well, there's about 8 moments, is what we call it, of data. Velocity, the correlation coefficient, which is the difference. We can use the difference, ZDR, we call it differential reflectivity, V and KDP, spectrum width, and then there's some other derived products that we can also use. But these 4, which are reflectivity, velocity, storm relative velocity, which factors in the storm motion, that's how we can measure rotation a little bit. We can see the rotation easier, the correlation coefficient. And we use it not just for one slice, but in this case, in the scan that we're in, we have 14 different slices of the storm. So we will scan each storm starting at 0. It takes about 30 seconds to do a sweep, and then another sweep a little bit higher, another sweep a little bit higher. And that goes on constantly throughout the day and throughout our shifts. And typically the higher the reflectivity, the higher in the storm, the stronger the updraft, the more things that are being carried with it, and tends to produce higher potential for damaging wind and large hail. So with the storm that we had, this was on the 30th of June in the afternoon, produced 3-inch hail here east of Carterville and Craneville. And the storm at the time was producing pretty high reflectivities up to 38,000 feet. And as you can see, we issued warnings based on, in this case, I think we have warnings for golf ball size hail. It's difficult to estimate baseball size hail in real time. But we'll look at the reflectivity, we'll look at the velocity, and we can measure like the difference in the wind speed at the very top of the storm, because when it hits the stable layer, it'll spread out, and a faster updraft, which is carrying those winds, will spread out. We'll look at all of that every slice, and a full new slice comes in about once every 5 minutes. So every 30 seconds, we're getting new data, we're making decisions, and we're drawing up these warnings with a software called WarnGen that we have here in-house. So we'll click on the storm, we'll back it up, we'll do a few different things, and we'll draw little polygons. And so that takes about 30 to 60 seconds. So there may be some times where if you're watching live on TV, you see a tornado spin up. You go, what are they doing? What are they waiting on? Well, we're not waiting on anything. We're drawing the warning up. It just takes 30 or 40 seconds. Nowadays, you're seeing the data at the exact same time we are. It's coming in, it gets processed by the radar, it's visible to us, it's visible to you at the same time, and then we're reacting to it 30 to 40 seconds sometimes. Or then sometimes, and I'll show you an example, we're kind of going, this is really something that I want to set everybody's phones off. Is this worth a warning? So we're taking a second to make those decisions. Not very many seconds, though. In this case, we got a couple reports of baseball-sized hail, though, and we issued a what we call a destructive tag severe thunderstorm warning. It said these are destructive storms for Galatia for baseball-sized hail and 60-mile-per-hour wind gusts, and that would have set your phones off in the Galatia, El Dorado, Harrisburg area for that severe thunderstorm. Now, for an example of a storm where we're not sure it's worth the trouble, but ultimately I decided that it was, this is from July the 2nd. So we've got winds heading into the radar down low, the lowest slice, at 50 to 70 miles per hour is what I was getting. So we had a severe thunderstorm warning out ahead of it, and it's not a perfect match to the winds at 3,000 feet, to the winds at the surface. And the winds that are coming towards the radar, if the storm is moving perpendicular to the radar, we can't see the winds. And so how perpendicular the storm is, or how parallel the storm is to the radar beam, can really determine what we can and can't see. And we have to extrapolate sometimes. Well, it's blowing like this here, and I bet it's blowing like this here. That's another area where we can end up with a warning for 60 mile per hour winds, and we only end up with 30 or 40 mile per hour winds because we can't tell exactly, and we're having to make an educated assessment, educated guess based on the winds that we can see. We heard folks talk about, we see a lot more tornado warnings than we used to. We see a few more tornado warnings than we used to, but it's because we're able to see a whole lot more than we used to be. This is an example in the afternoon of a storm in northern Ballard County. At this point, we've got inbound winds here, the 50 to 60 miles an hour. I have a severe thunderstorm warning up for all of this. And even in this storm, you can see this area here is 30, 40 miles an hour inbound, but it's at an angle, so I'm assuming it's about 60. This area is 60. This area is not. So right around Olmsted, it's just not as strong. Around New Grand Chain, it's stronger. It maybe starts to get a little weaker around Cypress, but it's difficult to know because how much of the beam angle is affecting it. So in this case, I was the warning forecaster in this situation. I issued a large severe thunderstorm warning covering all of the area because we had been getting reports of wind all afternoon and the environment was favorable. But then this little situation developed right here. And we got red going towards the radar, green away. We got pretty good rotation there. So I am faced with, it's not really a tornado day, but I only have one product that I can develop for tornadoes. And that's a tornado warning. In this case, I went, let's see if it holds up for another slice, and then 2 minutes later it did. And it held up over the course of about 3/4 of a mile. I had about 60 miles an hour of circulation. This is not particularly strong tornado circulation, but it was a tornado circulation. And it's something that in 2000 we would have never seen. The resolution of the data, we'd have never even known it was there. But I did know it was there. It was headed for Joppa and parts of northern McCracken County, southwestern Massac County. So we issued a tornado warning. I made it as small as I could possibly do because I didn't want to bother people in Brownfield and Golconda, Brookport and Paducah, because I knew it was going to be a very short-lived, very small, it wasn't going to last very long. There was no way. And it didn't. By the time I got the warning out, honestly, it was already starting to come apart. There was some damage in northern Ballard County, northwestern McCracken County. We issued a tornado warning. By this point, the circulation started to disappear. We canceled the tornado warning. It was in effect, I think, for like 11 minutes. But everybody's weather radios and all the phones and everything went off. Tornado warning, sirens are going off, and people are expecting like a December the 10th type tornado, perhaps. But that wasn't the case. In this case, it was, as you can see in the warning, radar indicated rotation, which is what we had. And, tornado warning till 3:45 for about 25 minutes for the area that we had. And you could say, well, we didn't get a big tornado, so maybe it wasn't worth bothering everybody. But tell the people in Joppa that. I can't in good conscience go, well, it's not the big place. It's not. No, there are people in the way. I was a trainer before I was back in the forecasting, and I always told folks, make the decision that you would make if it were your family in the way. What would you tell them? And so that was the decision that we made, and I think most of you understand that. We had a couple of other incidences that were similar on the, you say, how can we tell that the radar is producing a tornado? Radar is confirming a tornado. We had some confusion about that, I think, with this past event, and it's something that we've also not been able to do for very long. We've only been able to do this for about 3 or 4 years. So this is northern Grace County on the evening of the 1st. We had a severe thunderstorm warning up for northeastern Graves County, and this right here is in correlation coefficient is the difference. And what's funny, it's difficult. This is not a tornado right here. This is just inflow wind. This, it's like we were looking at it and go, that could be a tornado. The circulation's weak, but that could be a tornado. Step forward, it's still there. Right there, we say, okay, we got a warning on that. We issued a tornado warning, and then it tracked on. And in this case, redeveloped and produced quite a bit of damage in the north part of land between the lakes. And you can see here is probably some tornado debris. I'm not sure what that was. It was ambiguous. But this was pretty clearly tornado debris. And the reason that we can tell is because only tornadoes pick up and loft debris to 6,000 or 8,000 feet. There's stuff there that's not supposed to be there. Straight line winds will blow things around, but it'll put it at like 1,000 feet. The tornado has that deep uplifting force to where it's got to be a tornado. Now this storm in particular, it ended up actually producing a tornado the entire time it was tracking. It was a very weak tornado, but it was actually doing damage the whole time. We only got debris indicated loft up high enough, in this case the radar beams at 2,100 feet, that high for a couple of slices, but it was enough for us to see it and issue a warning. And this is another tornado that 2004, we would have never, no way we would have seen it. With the resolution of the radar, we wouldn't have been able to see the debris. Without the confirmation, we may have issued a tornado warning on this, but we might not have. And you've also got to look and see, this is a pretty small tornado warning, but north side of Benton didn't have any trouble. Oak Level didn't have any trouble. Sharp, they got some wind. Bridesburg, it was okay. There was a lot of area that still was in the warning, Calvert City, that didn't have trouble, but we're only giving about 5 miles buffer either side, so we were cutting it pretty tight. So you're still going to get those alerts, you're still going to get the weather. The tornado itself is only 100 yards wide, so you're naturally going to get an alert for more area than what the threat is. There's just no way around that. Maybe in 2060 we'll be able to pinpoint it to a few blocks, but it's just where we're at right now. I kind of doubt it. Where other tornadoes, this was a really weak tornado. It produced a tornado debris signature that we honestly didn't even catch right away because it was just 1 pixel. Whereas on March the 3rd, we've got all this wind coming to you, and this is like 70, 75 miles an hour. So we issued a big severe thunderstorm warning, and honestly, if I had this event to do over again, I think I would have went 80 because we had enough wind damage, and we were getting 74, 75 mile an hour wind gusts. Probably should have went higher. And we always reevaluate our decision making. Here, you got a little tornado that spun up that quick. So 0 at 11:05, we got a circulation. At 11:07, it's pretty clear we got a tornado developing. We issued a tornado warning by 11:08. It went out at 11:08, 11:09, as fast as I could get it out. And then we have another little circulation right there. You can see that's a much bigger tornado debris signature. This was an EF2 tornado. We could only get ahead of it by a few minutes because that was all that was obvious. Now the severe thunderstorm warning, if you're in Fredonia, Eddyville, Salem, Paducah, you've been under a severe thunderstorm warning at this point for 20 or 25 minutes before the storms actually got there. But we're looking at all this different stuff, and down here you can't see the wind as well, but it's because the beam angle is kind of funky. We're here where we're shooting directly into it. I'm getting 74, 76, 73 mile per hour inbound winds at like 400 feet, really close to the ground. We knew this storm was blowing hard. And then same thing was true for this storm on April 5th in Bollinger County. There is so for this storm, it's a good example of kind of the up and down potential of warning. So we issued a tornado warning about this point, and then none of the area here in northeastern Wayne County ended up getting a tornado. We got a warning out. We're waking them up. This is 3:30 in the morning. Nothing happens for them, and it isn't until about right there that the tornado actually touches down, and you can see the debris start to show up, and it was lofted to 12,000 feet. And so up into that point, these folks, they got a very high-end EF2 tornado that straight line wind, 70 miles per hour, radar indicated rotation. And then it was not radar indicated rotation. It became a radar confirmed tornado. We didn't get spotters that reported this in the middle of the night. We went based on that because the only thing that could be is a tornado. And then we also upgraded our warning to what we call a considerable tag, which we used on December the 10th as well. Say this, a confirmed large and extremely dangerous tornado. This is a particular dangerous situation, which we use for EF2 and stronger tornadoes. This is another thing that we could not do even 5 to 6 years ago in terms of assessing a tornado in real time. This is a big tornado, destructive tornado. We could do it if we had spotters. Now we can do it with the radar. And so we got a warning out downstream for Cape Girardeau County to say particularly dangerous situation for this area. And then by the time it got to Cape Girardeau County, fortunately, it had come apart and it never made it. We canceled the warning. We downgraded the warning to radar confirmed general base tornado warning, and then we canceled it outright when it was clear the threat had dissipated. But we're looking at this. So this is at 8:41:28 Zulu. So that's 3:41 in the morning, 3:43:18 344, 52, and we're getting new slices of data aloft, every 15 or 30 seconds to make these decisions, to put these warnings out. And we don't always have all the information that we need. Here's another example of a situation. This was July the 1st in the Mount Vernon area. We made a decision to go with an 80 mile per hour severe thunderstorm warning. We'd issued a 70 mile per hour warning 15, 20 minutes ahead of time. It was a pretty easy decision. We were getting lots of damage. And then we went with this 80 mile per hour warning here, and I'm getting 79.6 knots, about 89, 90 miles an hour inbound, 5,700 feet. And I have no way to know how much of that's reaching the ground. And you can see too, look at all this purple. We've got lots of bad data in here. Very incomplete picture because I'm almost 60 miles from the radar at this point. So we have the choice to go, well, you want to wait and see when it hits what we're going to do, or are we going to warn folks, and we're going to go with the preponderance of the evidence and go with a warning, and then that naturally results sometimes in, okay, it wasn't that bad. In this case, at Mount Vernon, I think it was pretty bad. I think we had 103 mile per hour recorded wind gusts with this storm, so it was every bit as bad as it looked on the radar, but we had no way to know for sure, other than the fact we were getting lots of damage here in Washington County, Illinois. We knew it was probably pretty bad. And then it weakened a little bit, and we issued a 70 mile per hour warning downstream, I believe. By this point, I downgraded it to 60, I think. But to this point, 70 mile per hour, trained weather spotters being included in the warning. And all of these things, these little details in the warnings, were something we just could not do even 5 and 6 years ago. The tornado emergency that we saw on December 10th was a product that had existed, but we had never used. We never had a call to use tornado emergency for Mayfield, on that horrific night. You can see the difference in the radar data and the radar presentation. The debris is over miles compared to the little pixels that we were seeing. And the characteristics give us the information we need to up the messaging and say, this is, and even this warning, the initial warning for Mayfield was one of these particularly dangerous situation tornado warnings, the level 2 of 3, where we went level 3 of 3 as the storm went into Mayfield. And we were able to ascertain the intensity was extreme based on the winds that were coming in and out. But even then, it was very messy because there was so much debris and things like that. So we're having to piece together a lot of information, and make decisions before we know for sure what's happening, because that's what we have to do. We can't wait till it hits, because it does you no good for us to wait and say, oh, what'd you get? Oh, well, that's cool. It doesn't help anybody. So in this case too, one more example, we had, this was in the afternoon. This is a warning that I think if I had, I don't know if I could have done anything any differently here. We had inbound winds here. We got downbursts going on here. We got downbursts going on here. We ended up with some wind damage here. By the time it got to Paducah, starting to come down a little bit, but by that point we'd already issued a warning. And then we ended up getting, it was 40, 45, 50 miles an hour, but it wasn't really truly severe as it got there. And we ended up, I think I put the middle of Paducah under 3 different warnings, which folks were like, man, it wasn't that bad. Well, just the way the warnings played out. I drew up one, new storm developed there, and I'm going to cover them until when they expire, and then it's getting ready to expire, so I'm going to issue a new warning, and you end up with just lots of different warnings. So it can get a little messy, and then I think that was about the time we had that was actually the earlier storm. We had the 70 mile an hour wind gust recorded in a Round Knob. But it can be a little messy just naturally based on the information that we don't have. We try to be as clear as we can. We communicate with our partners. We're monitoring the chat right now. We've got all kinds of different media partners where we'll be feeding them information. We have a new version of that chat where we can share pictures and images. We've got all the different media partners and our broadcast partners in there. We're constantly trying to feed them information. We're getting new information out. Most of the time it works reasonably well, but every now and then it can be a little confusing. And especially since we've added these new things, folks were especially concerned. We can see tornadoes via the radar now. Not all of them. We can't even see the rotation in some tornadoes, but we can see debris, and we can go with a confirmed tornado based on the radar. We can go 70, 80 mile an hour and set your cell phones off for severe thunderstorm warnings, and we can also see a lot more severe thunderstorms and tornadoes than we could see, 15 or 20 years ago, 30 years ago, because we have improved our radar technology. It's still the same radar that we've had since 1995, but we've improved the hardware and the software and our science and our interpretation of it. So you probably get a few more warnings now than you used to, but you also will miss a lot fewer events than what we used to. It wasn't uncommon, there are EF3 and EF4 tornadoes in the late 80s and 90s that we would never see, just because of the technology that we had in the 70s and 80s. Well, now we're going to see most of those, hopefully, by using all this different information. It gets harder the further away from the radar you get. I know the folks that live in like Carter and Ripley County, Missouri understand that, and we have to make different decisions. They're going to end up with more what we call false alarms there, because we know we can't see, so we're going to err on the side of warning. Sometimes out there, we're closer in, we can be a little more precise. But sometimes it gets messy. We should be a little bit quieter for a week or two, and hopefully, since we haven't been that busy in 20 or 30 years, maybe we'll go another 20 or 30 years without having that many warnings in a day. But I wanted to give you some insight into the decision-making process. We evaluate every event, try to get better. This one went reasonably well, except we had 200 and some odd reports, a lot, for 150 some odd warnings. But no injuries, and that's really what we're aiming for. No serious injuries. Nobody was injured, nobody was killed. We all made it through, and that's what we're aiming for. We'll make those decisions. It was just 160 mile an hour wind gusts. Yeah, but what if it hits a mobile home and blows it over? What if it hits a tree and blows it into a house? And there's a family inside. What if folks are sitting out on Kentucky Lake, on the 4th of July weekend in a boat, and the 60 mile an hour wind is going to capsize their vessel, which that did happen, I'm pretty sure, this weekend. Some of our lakes. So there's like a million different things that we're thinking about. Our broadcast partners are thinking about when we're making these decisions. So that's just some insight we wanted to record because we had a moment to do it. Hopefully it was informative, and we'll try to answer questions. If we have, we'll post this on Facebook and on YouTube. Have a pleasant evening.